everyone. Hey, it's 11:15, so we're gonna get started. This is our final speaker of the semester and the year, I realize. So congratulations. And it's the return of one of our alumni. He sat in your seat, so I won't steal all Pat's thunder to let him introduce. But thanks for coming.
So I don't know what's on quiz 8, but it's tomorrow. So I'm ready for that. So I don't know, grading that, it's not me though. So thank you all being here, as Steve said, for the final seminar for the semester. It's a real treat to have an alumni back, to have Brad Wilkinson here to speak today. So Brad was a PhD student here in our department just a few years ago. One thing that's nice about the crowd we have today is when Brad defended, the people in the room were me, him, and one other person. Everybody else was on Zoom because it was during COVID. So it's nice to have a crowd finally come here and speak. Brad is currently, and I had to write this down because it's complicated, the Bird Conservation Program Manager for the Association of Fish and Wildlife Agencies. And also he's the coordinator for the U.S. North American Bird Conservation Initiative. So as I said, Brad got his PhD here in our department. He got his master's degree at San Jose State University, where he studied spatial ecology of rhinoceros aquats. And he got his bachelor's degree in zoology at Miami University of Ohio. So with that, I'll let Brad finish up introducing his work. Thank you again for all being here.
Thanks for the introduction, Pat. It is great to be back. I was telling him I defended in December of 2021. So it's been just the perfect amount of time where I'm still familiar with campus and familiar with the building, but long enough where I'm like, oh, that building's different, or that wasn't here before. So I'm excited to see the changes. Like I said, I'm excited to be back. So I want to talk a little bit today about some of the perspectives that I've had in my current position about bridging the research implementation gap. When I was a student, I was really interested in having my work contribute positively to conservation and bird conservation specifically. And since I've graduated, I think I've learned a little bit more about how policymakers and decision makers use the work that comes out of our academic institutions. And so I'm hoping that can impart a little bit of wisdom, maybe as you think about the work you're doing now or the work you might do in the future, how your work really contributes to conservation, because I think almost everyone here wants their work to be used and have an impact in some way. So as Pat mentioned, I thought I'd bring a little bit of my personal history. I graduated from Miami, Ohio in 2013 after a lot of time looking at birds as a hobby. I started bird watching when I was in elementary school, 4th grade, and I continued that all through my whole life. So I always knew I wanted to do something with birds. And then after graduating with my BS, I bounced around to a couple different places doing field tech work before I started a master's degree at San Jose State University, studying a seabird called the rhinoceros auklet off the coast of California. And that really got me interested in seabird work and telemetry and movement ecology. I took the skills I learned there to Clemson here with Dr. Patrick Jodis, where I finished, like I said, in 2021, my Ph.D. looking at the movement ecology of brown pelicans on the coast of South Carolina and elsewhere. And then after I graduated, I took a postdoc at Duke University, studying northern elephant seals and trying to understand how they navigate throughout the open ocean using celestial cues or geomagnetic cues. But throughout the course of my graduate career, I've had a couple focal areas of research interest areas, I would say. So obviously, I think I'll always enjoy seabird biology and seabird ecology. It's the bulk of my training, and I'll also probably always enjoy animal telemetry and movement ecology. But I'm really interested in understanding how both ecology and telemetry contributes to full annual cycle conservation. When I say that, I mean specifically in the context of avian conservation. How do we protect birds throughout the full year wherever they are? A lot of our migratory birds are traveling, not just outside of their breeding areas, but spanning the entire hemisphere. And we need to be doing conservation work wherever those birds are located. And so that's kind of what I mean when I say full annual cycle conservation, not just habitat management on the breeding grounds, but on stopover locations, wintering locations. I also got interested in big data and machine learning during my postdoc. It's really hard to infer any sort of navigational sense without having a gigantic data set. And so that was something that I continued to be interested in, is understanding how those two things work towards our research goals as well. I dabbled a little bit in ecotoxicology, specifically PFAS work while I was here at Clemson. But now my focus has really shifted to conservation policy. So in my current role, which I'll talk about a little bit, it's given me an interesting perspective, I think, on how policymakers and decision makers use the information that's coming out of, like I said, our academic institutions. So that forms kind of the background of kind of where I'm coming from, the basis for this talk. As Pat mentioned, I'm currently the Bird Conservation Program Manager for the Association of Fish and Wildlife Agencies, and I'm also the U.S. Coordinator for the North American Bird Conservation Initiative. I realize that probably most of you in this room don't know what AFWA is. So AFWA is a 501c6 nonprofit trade organization. So we don't represent industry or anything like that. The group that we represent are the state fish and wildlife agencies throughout all 50 states, US territories, and Canadian provinces. So we work to represent all of those state agencies legislatively on Capitol Hill and before the administration to advance favorable fish and wildlife conservation policy. We also work to secure funding for different programs that state agencies are involved in, and we help ensure that our state agencies are working collaboratively, on the most important issues with federal partners, with NGO partners, things like that. We also provide our member agencies with coordination services on topics or issues, and these could be specific topics or like taxonomic-based programs. So for example, we have a bird program, which is what I run. We have fish habitat, we have energy development, climate change. We're heavily involved in state wildlife action plan coordination, conservation education, leadership training, things like that. And so I like to describe AFWA as having kind of two main parts. The engine of AFWA is our government affairs team, who, like I said, are really representing our state agencies on the Hill. And then we have our science team, which I'm a part of. And the science team is providing information to our policy team. It's providing information to our state agencies, understanding what the priorities of the state agencies are, and merging that with the best available science to give to our policy team. So really kind of split into two things. So I'm not specifically like a lobbyist on the Hill, but we employ lobbyists, and I work with them to get our policy through to decision makers. So the other thing that I help do is, like I said, I'm the US coordinator for the North American Bird Conservation Initiative, and this is somewhat similar. NAPC is a coalition of state and federal government agencies, private organizations such as NGOs, and the different bird initiatives, all working on continental scale bird conservation in the United States. NAPC exists to be kind of an informational clearinghouse, a place where all of our different agencies and entities working together can come and share information, learn from each other, set priorities, set goals, work through issues in a structured decision-making kind of framework. So I'm the coordinator for that. I'm not necessarily the one who's making these high-level decisions, but I provide the space for leadership from all of these agencies and organizations to come together to talk through high-level continent scale bird conservation. NAPC and AFWA share a lot of similarities in my role insofar as that I'm convening leadership, convening places to have this exchange of science to policy and to decision makers, but there is some distinction there. The goal or the mission of NAPC is to facilitate partnerships that are advancing biological, social, and scientific priorities for bird conservation. I really want to highlight there the social component. NAPC is a little bit different than other bird conservation initiatives insofar as that we really have a strong focus on social science. We employ or work with a full-time social scientist to make sure that what we're doing is working for private landowners, for the public, that the message is getting out there and it's received by not just the scientists and decision makers, but the people on a broader scale. And then the vision for all of this work is to have healthy and abundant populations of North American birds that are valued by future generations and sustained by habitats that once again benefit both birds and both people. The people component there is really big. Like I said, we know when we have specific goals in mind for bird conservation, but we also understand that people need to have space as well. So with that, I'm going to get into kind of the bulk of what I want to talk about. And before I get started, I just want to say that most of what I'm going to present is based on two pieces of literature that I would highly recommend folks taking a look at. The first is a paper by Saunders et al. Published in 2021 called Bridging the Research Implementation Gap with Translational Ecology, published in the Condor. If you're interested in this talk and the kind of takeaways from this, I would highly recommend reading that paper It goes into more detail what I'm going to be talking about and provides a lot more examples of some of the frameworks that I'm going to discuss. But it's really, I think, a very short, nice, succinct paper that is going to talk about avenues for, like I said, bridging that gap. And then the second thing is a paper that I'm currently involved with, being led by a colleague, Rachel Buxton, called Successes and Opportunities for Solutions-Oriented Conservation Research. It's fairly similar. It's got a couple different names in there, but we're trying to kind of follow up the Saunders paper with more examples and talk about how we can produce solutions in conservation research that work for birds and people and diverse perspectives. So we're hoping to have that paper finished and out by the next 7 to 8 months. Like I said, I'm a contributor. I'm not the one leading it, so the timeline's a little hazy. But whenever that gets published, keep that in mind as well. So as it's clear now to you all, I'm interested in birds and bird conservation. Some of you may have seen this paper that was published in 2019. It kind of was a pretty big deal, highlighting the fact that since 1970, so over the past 50 years, North America has lost nearly 3 billion birds. If you saw the kind of title slide I had at the beginning, that's 1 in 4 birds from North America that have collectively disappeared over the past 50 years. And so the bird conservation community since 2019 has kind of been in a crisis mode, I would call it. There's been an understanding that bird populations have been declining, but now that there's a kind of a specific number to it, it's really brought it to the forefront. And it's, part of it's driven by threatened, declining species becoming more threatened, but a big part of it is being driven by common birds becoming no longer common. So your things like blackbirds, sparrows, finches, those are really taking a big hit. And so we're seeing more birds that used to be common or somewhat common sliding into that threatened territory. So we know that we have these big declines of birds and bird populations across the continent. And yet we also know that bird watching is arguably the most popular that it's ever been. So in 2022, Fish and Wildlife Service came out with their 5-year incremental survey of North American wildlife recreation habits. And the results of that survey indicated that over 90 million Americans every year participate in bird watching to some extent, which is a huge number. That survey happens every 5 years and they change the methodology from this year to the previous iteration. So the numbers aren't directly comparable, but we can safely say that more people are participating in bird watching now than have ever been. The second result of that survey was that wildlife watching contributes over $250 billion directly to the US economy every year. Bird watching is not responsible for that whole $250 billion, but it is far and away the largest part of that contribution. And when I say contributes to the economy, that's direct spending. That doesn't account for all of the ancillary services, production value, things that get into that. So if you actually add like the total economic value of wildlife watching, it's more in the realm of like $800 or $900 billion per year. So we have these kind of two facts that, bird watching is probably the most popular it's ever been. It's stimulating a large part or a large section of the US economy. And yet over the past 50 years, there have been the fewest amount of birds to be seen. And so the question I have is, kind of how do we resolve this paradox? And I don't love the word paradox here. It's not exactly what I want to get at, but I couldn't think of a better word to illustrate the fact that we have these two shifting trend lines, an increase in bird watchers and yet a decrease in the birds available to be seen. So how do we kind of make those lines come together? And I would argue the only way to do that, or one of the tools that we need to do that, is to produce conservation science that's useful, that's relevant, and that's practical for policymakers and decision makers, and then by extension, the public. We have a large public constituency that's interested now in birds and bird watching. They're getting the attention of policymakers and decision makers. And on this side of the equation, we need to be producing science, conservation science that's useful and relevant to those groups. So I wanted to take a look and kind of ask ourselves, how are we doing in the realm of conservation science, producing that relevant, useful information for our policymakers? So this paper by Williams, 2020, I think does a good job kind of summarizing some of the high level points. They took a sample of 1,000 peer-reviewed papers that were published specifically in conservation journals over the past 2 decades, and kind of asked the question, how useful is this to a decision maker or a policymaker? Is this having a tangible impact on conservation science? And they kind of lumped these papers into a couple of categories. And some of the highlights that I want to share, 43% of the papers that they looked at were simply a description of the related figure. So what I mean when I say this is this was a paper that looked at a population of birds or a population of mammals and described that they've declined, they've increased, how is the population doing? That was nearly half of those papers, was just a simple description of, over this amount of time, this population has done this. There was not any sort of like follow-up or mechanism proposed about why that might be the case. It was, like I said, really just a reporting. 70% of papers that they looked at didn't propose any sort of response to the observed change that they had. So this paper might have been reporting a population decline or a population increase, but there was no recommendation for what could be done to either halt that decline or why this population has increased. It was just, like I said, that kind of description. Only 10% of the papers that they looked at actually linked any sort of mechanism to that source or that driver of change. These would be papers that actually said, we had this decline, we think that this is going on. And then a smaller subset of that actually was able to say definitively this change occurred, which led to this population decline. So very few of the studies that they ever looked at, kind of in summary, ever really reached this next step, as I would call it, which is designing some sort of workable socioeconomically realistic intervention that related to the decline or the increase in this species, whatever they were looking at. And then even fewer of those reported any sort of results of implementation. So out of all the papers that they looked at, there was really only a handful that said, this species or this population is declining. We've designed some sort of realistic approach to halt this decline. And then we've actually tested it and gone out and see if it's made a measurable impact. And I just want to emphasize, these are papers that are being published in conservation specific journals. These are not, your sciences, your natures, your taxon specific journals. These are meant to be conservation specific papers. So on the other side of the equation, how are policy and decision makers doing? That's kind of the science producing part. How are the science users doing? This paper by Sutherland and Wordley et al. Did a pretty good job explaining some of the issues that we see from the policy decision-making side. A lot of people that are actually doing our decision-making along with conservation practitioners really continue to rely significantly on 2 forms of information. And that information is either personal experiences and anecdotes or maintenance of traditional decisions. So a lot of people who are crafting our policy or who are making decisions are not necessarily checking the literature. They're thinking, I have experience in this area, or someone I know has had personal experience in this area. I'm going to make my decision based on not necessarily what I feel, but my own kind of assumptions or understanding of how this operates. Or they're confronted with a recurring problem and they look at the problem and say, well, what was done in the past? I'm going to do that again because that's what we've always done. So this kind of component of decision making is sometimes referred to as evidence complacency. And I want to make sure that you're not taking away an assumption that I'm kind of placing a blame on policy or decision makers for being like lazy or complacent or anything about how they're making their decisions. The fact of the matter is most of our policy and decision makers are just confronted with a ton of different things that don't necessarily involve management or scientific decision making. They're administering large programs. They're concerned with budgets. They're concerned with staff personnel. A lot of times they just don't have the time or the effort or I hate to say the word luxury, but luxury to go into the science and actually find out what the latest is on whatever problem they're trying to solve. So we have this kind of Venn diagram here between science producers and science users. Our science producers are going to be our conservation biologists, academic researchers, ecologists, the people that are actually producing our science. And then we have our science users, like I said, our policymakers, practitioners. The public and the media are included as science users because they do consume the science that's produced. It's important to remember that as we produce our science, it is being consumed not only by people who are influential in making decisions, but by the general public at large. So in the middle there, we have what the Saunders et al. Paper called knowledge brokers, which I really like that term. These are folks or institutions who are bridging that gap between production of science and the use of science. And I also I really like this Venn diagram specifically because some of our knowledge brokers, some of the organizations that act as knowledge brokers are doing both production and use. So for example, a large NGO might employ scientists who conduct studies, but then who give that information directly to people within that organization who have control over land or who have policymakers on staff or who have access to policymakers. So sometimes this kind of Venn diagram is held within one certain organization. Other times, these knowledge brokers, that's kind of all they do. So like my role at AFLA, I would consider myself a knowledge broker, but I'm not producing science. AFLA doesn't produce science. We're also not making decisions, but we're facilitating that transfer of knowledge. So like I said, I really like the fact that it's kind of so some examples of the knowledge brokers that I think are useful are, like I said, NGOs, some university extensions. I would include the cooperative economic research units in there, and then our government agencies often act as knowledge brokers as well. So I'm hoping to impart to you all the fact that it's my opinion, the null model of kind of transfer of information is both passive and unidirectional, and by and large, not functional for achieving the goals of conservation that we want to achieve. When we think about transfer of information, especially from academic circles, we often consider those methods to be something like publishing your results in a scientific journal, crafting a poster, going to a conference and giving a talk. And I'm not discouraging anyone in the room from doing those things. Those are, fantastic things to do, and we need to continue doing that. But if that's the only model that you have for transferring information to policymakers and decision makers, by and large, it's not going to be effective. I would say this is particularly true for certain aspects of policy. Policymakers often are so far removed from what I would consider kind of the sciences that they really need to be, something needs to be put directly in their face before they're going to notice it. And even then they're dealing with a multitude of competing interests. There are exceptions to this model where it is successful. I would consider like threatened or endangered species to be one way that this unidirectional passive transfer of knowledge is actually incorporated. An example here from Clemson that is kind of close to home. The JODIS lab has done some really great work with black-cap petrels, and black-cap petrels were recently put on the endangered species list. And in that listing decision, they referenced some of the papers that Pat and the lab have put together. And you can correct me if I'm wrong, Pat, but I don't think you were necessarily handing those papers directly to the folks who are making the listing decision. So it does happen, but it's far and away the exception more so than the rule. So this kind of brings us to the conclusion that alternative models for the transfer of information is needed beyond kind of this null model of what we're used to. And there's a couple different models that have different details, but all kind of get at the same thing, and they all have different names. So you might come across this as being referred to as translational ecology, the co-production of science, solutions-oriented research, use-inspired science. All of these terms more or less mean the same thing. And it's taking an active approach to the brokering of knowledge between producers and users. It's getting away from a unidirectional passive approach to taking this active collaborative approach to producing science. So throughout the course of your careers, your graduate student training, you might come across different terms, but I'm more or less referring to these as all kind of the same model. And within the field of kind of translational ecology specifically, there's 6 principles that I think cut across all of these different forms that really are hallmarks of this kind of active approach to bridging this gap. And those principles are collaboration, engagement, commitment, communication, process, and decision making. And I'll go through what kind of each one of those means. But a good, well-managed translational ecology project should bear the hallmarks of all these principles. So the first hallmark is true collaboration. And true collaboration is formed when teams of both users and producers organize with the intent of developing a project to address a specific goal. Shared knowledge is developed, decisions are made and defined by all parties at the outset. You can think of this as expectation setting. But true collaboration requires a diversity of perspectives and a diversity of approaches to challenges as well. These are not necessarily steps to be followed in order, but if you were going to think of these as steps, I would say this is the first one. So I wouldn't think of this as like a checklist of things to do in order, but like I said, you really need to have an honest understanding and an honest desire to collaborate to form these sort of projects, which I'm going to be referring to. The second is engagement. Engagement supports the desire to collaborate. It fosters relationship. It's hallmarked by open dialogue that occurs in structured and defined spaces. Engagement is kind of the realm of the knowledge broker. Knowledge brokers are often the people who are putting together the either physical or virtual convening space. Knowledge brokers are often designing what the conversations are going to look like. They're going through the iterative process of understanding the challenges, understanding the needs of the different people who are in that relationship. And so I would stress that of all the different kind of hallmarks, knowledge brokers specifically are most involved with engagement and providing space for engagement to occur. The third hallmark is commitment. Commitment is required for maintaining trust and accountability. And this is especially important for these types of translational ecology projects, which involve multidisciplinary factions. They're often very prolonged. It takes a long time to understand the needs and the perspectives and the challenges that go along with impactful conservation science. And so there needs to be a commitment from all parties involved that you're going to be in it for the long haul. And really it's inherent to this kind of approach to conservation science. The fourth hallmark is communication that is straightforward and honest. It also requires active listening to diverse perspectives, and I would really emphasize active listening. I've seen collaborative approaches break down where groups of parties or groups of individuals come in saying that they're going to communicate, they're going to be engaged, they're going to collaborate until a different party says something that they don't like, and then they disengage and stop communicating. And so really active listening depends on the fact that you may hear something that you weren't prepared to, or that at the outset you weren't interested in hearing, but you need to fully understand the perspectives of the different communities coming in. The fifth hallmark is designing a process that's going to lead to a specific outcome. This leads to a sense of project ownership and investment in the project. There needs to be some sort of designed space for dialogue to occur, whether that's a series of workshops, different conferences or different planning stages, things that you have that are concrete, that everyone knows what the process is going to look like before it actually starts developing. This provides a framework for applying the results of your science producers to the problem that users have, and also implies a continual learning exchange. If you have a defined process at the outset, it leads to that commitment and that communication, because you know that this is the first meeting out of 7 that we're going to have, or the first meeting out of 10. And so, we're going to go through this process iteratively, and I know what that process looks like from the outset. A very similar hallmark that's a little bit different is decision framing. Decision framing enables the outcomes of a decision that accounts for the needs, the values, the resources, and the timeline of users. So this is similar insofar as that, when you're designing a process, you want the end goal to hopefully come to what I would call a decision tree, for example, where if you have this specific scenario that you've occurred to at the end of your process, we're going to make this decision. If the scenario B pans out, then we're going to make this decision instead. If for some reason we're at scenario C, then this is the decision that we're going to make. And this allows for that iterative learning. It allows for the project to end, but if there's something that comes up in the future, it allows you to revisit the decisions that were made and understand, now things have changed. We're at this specific point, we need to make a new decision. So it's all part of this collaborative, process-driven framework for making important decisions that are, like I said, valued by both the people who are producing the science, but really valued by the people who are using the science. So obviously, a desire to collaborate is that first prerequisite. You have to have a want to have your science or have your discoveries, the thing you're finding out, be used by ultimately end users. But this active engagement, I would argue, demands discussions about problems and solutions, and that's most effective via a knowledge broker. It's very challenging to, I would say, go directly from user to producer without having an outside broker to guide that process, to guide the decision framing, to set up spaces for the convening of all the interested parties, to maintain that over the long term. And I would argue that that's kind of where the real benefit of having knowledge brokers and these knowledge brokering systems come into play. At a recent meeting, a group of knowledge brokers like myself kind of came together and tried to define what successful conservation projects look like and kind of make a list of what we thought defined successful conservation on the ground for specifically avian ecology. This is kind of what we came up with. Successful projects have outcomes that first and foremost have a positive biological response. That's not the only success, but that's the primary metric of success for what we're talking about. We want to see a project that's developed that has some sort of impact on the study organism, the study population, the study species in a positive biological way. So I want to kind of say that at the outset. Other hallmarks of success, though, or other successful outcomes are changes in programs, changes in policy, changes in regulations, or changes in social systems that contribute to that positive biological response, or could contribute in theory to that positive biological response. So an example for this might be, having people buy bird-friendly coffee or bird-friendly chocolate because that is going to provide habitat on the ground in Central and South America. That's a positive change within a social system to get consumers thinking about how they're consuming a specific product. Or to have a building manager put to treat their glass on their building to reduce bird building collisions. That's kind of a social system change. Obviously, great when we can have changes in policy. Policy often changes back and forth depending on who the people are who are implementing the policy. Policy changes tend to be less durable for that reason. They're great when they happen. But true longevity in a policy shift is rare and uncommon. Programs and regulations are a little bit more durable than policy changes, but once again, those can also be done and undone depending on who the people are who are making those changes. So the processes that we most often listed when we kind of thought of these conservation success stories were processes that really that really drove home the building of relationships, the co-development of research questions at the outset, and that had a strong science translation component, not only to users, but to the public as well. These were iterative workshops. These were long-standing projects where the people who were going to be impacted by the decision came to the table at the forefront before a decision was made so that their perspectives were heard, and that were really guided by science, but also guided by the end result and the end impact first. So I want to emphasize that we see positive outcomes when we have these process-driven projects. So this all sounds great and nice. Obviously, there's barriers and there's caveats to doing this sort of work. And some of that is systemic and some of that is value-driven, I would argue. The academic funding model as it currently exists is really challenging towards building these long-term, trust-centered, process-driven projects, just because funding often has a short time scale associated with it. And it takes a really long time to gather people together to understand who's going to be impacted by a decision first and foremost, to design a scientific project that's going to answer the question that you want, and that will produce, like I said, a socioeconomically relevant, doable outcome at the end. It just takes a lot of time. And unfortunately, academic funding often occurs at timescales that are shorter than that. The second is how the promotion process and scientific recognition occurs within academic circles. Most often, we're being judged on the quality of our papers, impact factor, what journals were things published in. Those tend to skew towards theoretical science. Basic science tends to skew away from the kind of I don't know what to call it, the less impact factor heavy work that's being done. It doesn't reward reports or like white papers the same way that it rewards a scientific publication. And so there's some changing that may need to occur in how we value the work being done by academics. I would lump, like I said, kind of the scientific publishing model into that as well. The high impact journals, high impact factors are looking for brand new, different science. They're looking for, I guess, a kind of basic theoretical science often. And so that model may need to change if we're going to be producing science that's really relevant and really useful to decision makers. Curriculum and training can also act as a bit of a barrier. Graduate programs often don't teach relationship building. They don't necessarily teach people management. I think our curriculum and training is really great when it comes to learning coding or learning the scientific skills that it takes to be a scientist. And like I said, that's fantastic. But there needs to be some training that goes involved towards people management and relationship building and trust building, and active listening. I would throw in here too. Like active listening is not really taught in undergrad or graduate school or even beyond that. So it's often left up to the scientists. If you have a knack or a skill for it, then you can do it. But if you don't, then you just never learn how to. And unfortunately, it is something that can be taught, and it's not really. Another barrier to doing this type of work are often the timelines of when a decision needs to be made. So, like I said, these projects require long scale, long time frame solutions and problems, but sometimes we have decisions that need to be made right away. Sometimes there's something that comes up and it needs a decision, and you only have 8 months to a year to make that decision. That's not enough time to really go through this whole process of designing something that's relevant to that. And so the suggested way to overcome that is to anticipate what decisions might be made in the future, anticipate what the needs of different communities may be so that we can get started on those needs or those problems that we think are going to be an issue now, so that when that decision actually does need to be made in the future, we have we hopefully have a decision framework tool to support that. We can now say that we're ready to make that decision. The work that's been gone on previously is relevant to this, and so we have that information. But that's really tricky. It's really difficult to predict what a decision is going to be in the future. And then lastly, our competing objectives from both policy and decision makers. We'd like to think that conservation is at the forefront of everyone's mind when they're making a decision, but it's not. Conservation is often only one small piece of a large pie that decision makers, policymakers are needing to balance. And so, we need to make that argument as clearly and as best that we can. But to be frank, sometimes on the Hill, we're out lobbied by another interest, and that just happens. It's through no fault of our science or the evidence that we've compiled. We ultimately weren't selected for that decision. And unfortunately, like I said, that just kind of happens. I did, like I said, want to give a special shout out to the Cooperative Fish and Wildlife Research Unit program. I do think that within our academic circles, the cooperative unit is a great model for bridging some of these barriers. The units force you, through the way they're structured, to collaborate with state agencies, with federal agencies, to go to people who will be making decisions and understand what their problems are at the forefront, and then hopefully, get money to do that, bring in a student and have them plugged in. As a student, I think it's really challenging to undertake this type of work. Like as a master's student, you only have a couple years. If you spent your time designing a process like this, it'd be 2 or 3 years before you're ready to actually collect any data. It's not feasible. But there are programs that you can get plugged into to kind of do this as a graduate student. And then hopefully as you continue your careers as a graduate student or beyond, you kind of can take these lessons with you. But I want to, like I said, especially shout out the cooperative units for doing that. Part of the reason I have the job that I do have now is because I had experience in the unit. And I had experience working directly with a state agency. So I could, kind of roll right off the bat and say I understand the state agency perspective because I interacted with them as a graduate student. So the earlier you can begin doing that, I think the better. So I know this has all been kind of theoretically based, but I did want to talk about one kind of case study that I think exemplifies some of the different principles that I was talking about earlier. And that's the case of shaded agroforestry in primarily Central and South America. So for most of our neotropical migrating birds, our songbirds, they breed in the United States or Canada. Then they often migrate to areas like Colombia, Peru, Mexico, Panama, Costa Rica to spend a non-breeding area. And shaded agroforestry has really emerged as a whole topic unto itself for neotropical migratory songbird conservation. So what I mean, specifically when I talk about shaded agroforestry, I'm going to be taking the example of coffee, but this is also applicable to kind of some other realms as well. So the majority of coffee that is grown and consumed around the world comes from beans grown in plants that are produced in a monoculture in full sun. So this is an area of what used to be cloud forests or rainforests that have been kind of clear cutted, planted with a monoculture of coffee. There's no shade, there's no canopy overhead. It's just a field of coffee beans basically. And this is predominantly how coffee is produced now. But this was not always the case. There used to be back in like the 80s and before then, coffee produced primarily on small scale local farms on someone's land that typically did have a shaded canopy cover to it. It had some remaining trees, but as the growth of consumer coffee grew, the means of production grew to become more industrial, and this has led to that kind of monoculture. So in Mexico, Central America, and South America, our highest producing coffee regions also tend to be really high use for, like I said, our neotropical migratory birds during migration and non-breeding season. And around the 1990s, folks really started to notice that we're losing a lot of our neotropical migratory songbirds. We've seen this explosion of coffee monoculture during the non-breeding grounds. Is there a relationship there between those two things? And scientists, mostly based at the Smithsonian Migratory Bird Center, began trying to answer that question by undertaking surveys on coffee plant or coffee farms of shade coffee versus the sun coffee, and really quite quickly came to the conclusion that not only was shaded coffee much better for the local resident birds, it was also much better for our neotropical migratory songbirds. And the migratory songbirds were using, to a fairly broad extent, these shaded coffee farms. So this culminated in 1998 with the Migratory Bird Center creating a new label or a new certification that they call Bird Friendly Certified Coffee. And this label works by going to coffee producers who have done a certain amount of work on their land or preserved a certain amount of tree canopy overhead that meets a standard threshold for bird use, for avian use. So these standards obviously cannot just be picked out of thin air. They need to have scientific backing behind them. And so those standards had to be set in such a way that not only considered, how many trees are on your farm or how many trees are on your farm for migratory birds, but are you still producing enough coffee to make a living, to make an income? How is your coffee yield doing? Are the quality of your beans as good as full sun beans? Is this economically feasible for you to do? And so there's a balance there. Obviously, on the one end of the scale, we have primary virgin forest. On the other hand, we have full sun. Where in between can we set this threshold where it's economically viable for farmers, but still good for birds? And that's taken a lot of research, a lot of scientific expertise to find where that standard is. So while making that coffee, this label premium, you also have to understand that it can't be too expensive or otherwise the consumer is not going to buy it. So that's another consideration to have in there as well. Is it not only feasible for you to produce as a farmer, can you actually sell this at a price point that people are going to buy it? If it's too expensive, no one's going to buy it, then the farmer's going to go back to a full sun well. So you have this intersection here of needing robust biological science to understand how birds are using these farms. You have to have a social scientist to understand how farmers are impacted by converting to a shade-grown coffee farm. And you have to have some economic science in there to understand how can we sell this? What is the amount that we need to sell to make it viable? How do we scale it up to make it meaningful to a landscape? So as I said, over the past 20 years, since the introduction of that label, there's been considerable research that's been undertaken to refine those standards. Since the label first came out in 1998, there's been a lot of different changes. There's been, at first it was like, have trees, this number of trees, you want this amount of canopy cover. It's gotten to the point now where we know specific tree species which are best, the mix of those tree species that need to be on your land in order for it to be bird friendly. How much understory you need to have in addition to coffee, things like that. So it's really gone through a lot of refinement. It's also been economically successful. You can buy bird-friendly coffee anywhere you are in the United States, most places in Canada. It's been really successful for the growers themselves. They've been able to find a price point and kind of meet a threshold of mass where the beans that they produce are of a higher quality. The yields are a little bit less, but because they're selling it at a premium, they're actually making more money than they used to. And they also, they feel good about producing coffee that respects the land that they're on as well. So there's a value for the farmer there too, beyond just the economics, but in that relationship to the farm that they have. So the shaded agroforestry model, it kind of started in coffee, is now actually spreading to other commodities like cacao. So you can not quite buy bird-friendly chocolate, but that'll be coming soon. That's like the next big one that's being pushed. Bird-friendly cardamom. There's several programs that talk about bird-friendly ranching for beef production, where you have a certain amount of prairie or any type of grassland that's left in your rotational grazing areas. And then maple syrup's also like the big one down the line. And that one always kind of caught me. It's like, what's bird-friendly maple syrup? Sugar, they're called sugar bushes, which I have only recently learned, but that's like the term for a maple syrup farm. A lot of the maple syrup that's produced in the New England states specifically, their sugar bushes are actually monoculture crops of sugar maple. It doesn't necessarily compute because you look at it, it looks like a forest, but if you go in, you see it's all composed of one type of tree, and that's sugar maple. And it's not very useful for birds. And so there's standards that are being approached now to understand, how many maple trees you need to have in your sugar bush so that it is an economically viable method to make maple syrup, but how much taxonomic diversity do you need to have to make it useful for birds? And that area of research is only just now getting started. But it's that type of, understanding the needs of your producer, of the public, of the biologist to have those things come together. And so I just want to underscore the point here that each new commodity that's being researched demands unique needs. You can't apply the coffee model to maple syrup. You can't apply that to beef. You can't apply that to cardamom. So there's this whole burgeoning field out here of understanding how private agriculture can contribute to bird conservation. So you might be asking yourself, that's great, but how does this fit into like policy and decision making? I thought that's what we were talking about. And I would be here to remind you that science is also really needed to support the policy and the initiatives that go into funding this type of work. The money has to come from somewhere to get these projects started. And oftentimes it's policy and different initiatives that are supporting these kind of fledgling scientific programs. So in the realm of like bird-friendly coffee specifically, the concept of full annual cycle conservation is the #1 tool that we have for making the case for bird-friendly coffee in these areas. And it's been really helpful in driving some of our major policy initiatives. So on the federal level, we have something called the Neotropical Migratory Bird Conservation Act, which was first passed in 2000. They started issuing grants in 2002. This program has contributed directly over almost $95 million to support 747 projects in 43 countries. Not all of those projects are specifically related to shaded agroforestry, but since the inception of that program, a large number of them have been as a result, or have been going towards these shaded agroforestry projects. And it's for a number of reasons. The science is clear and digestible to policymakers that having these shaded agroforestry systems are helpful to birds. We have the documentation to back that up. In the absence of shaded agroforestry, you're going to have sun monocultures. You're going to be, no one's under the pretense that like a shaded agroforestry system is as good as a virgin cloud forest, but it's not as bad as a sun monoculture. And so we see more and more projects coming out of the Conservation Act fund supporting this agroforestry. This Neotropical Migratory Bird Conservation Act has to be reauthorized by Congress every 5 years. So it was reauthorized most recently in 2023. Every 5 years, the bird conservation community tries to make some changes to that program, whether that's increasing the amount of funding that's available through the appropriations process or lowering some of the match requirements that's involved. So for this program specifically, it was prior to 2023, the match ratio was 3-to-1, which meant that any person applying for grant dollars had to have $3 in hand for every $1 that the federal government would contribute. We were able this past go around to actually get that match requirement down to 2-to-1. So now a partner only needs $2 to match every $1 from the federal government. That's opening it up to a lot of new partners, a lot of smaller, more local growers or collectives that previously were excluded from applying because they couldn't get the capital, so to speak, to apply for this grant. So in 2028, we're going to have to go through it all again, and it's really nice to have the science, like I said, to back up the claims that we're making when we talk about that on the Hill. The other program that I actually help administer is called Southern Wings. It celebrated its 15th year just this year. This is similar to the Migratory Bird Conservation Act, but it's really only for states to contribute towards. So this program is a mechanism whereby state fish and wildlife agencies can give money to specific projects that are implemented by partners on the ground in Central and South America to do work that directly benefits their shared priority migratory bird species. So for an example, like the state of Tennessee would give money to an NGO who would then do on the ground work in Costa Rica to plant shaded cover crops on a farm, a coffee farm. And so this mechanism really depends on having sound science that we can bring to state fish and wildlife agency directors that tells them their birds are going to this area and you need to be contributing money towards this area if you're going to be successful. There's only so much work that a state fish and wildlife agency can do on the breeding grounds if it's not also being complemented by work on the non-breeding grounds. It's great if your work produces 1,000 new birds, but if 999 of them die in transit to Panama, then there's kind of a lot of wasted energy. So that program has been able to contribute $4.2 million over the past 15 years to support 29 projects in 12 countries. The migratory bird connectivity telemetry data has been huge in getting that program kind of off the ground. There's a lot of resistance early on by state fish and wildlife agency leadership saying, why should I give our state money towards a project that's occurring in Costa Rica? With the advent of telemetry, movement ecology, we can tell them, we tagged birds, we tagged a cerulean warbler in Kentucky, we followed it all the way down to Colombia and it wintered here, and you have a chance to do something on that wintering ground. Without that really specific connection data, it's a difficult challenge to overcome. I'd like to tell this story. When we were getting the Neotropical Migratory Bird Conservation Act reauthorized in front of Congress, I was not actually the person who was testifying before the House Natural Resources Committee, who was in charge of deciding whether or not to reauthorize this program. But I was in the room. I was standing behind the people who were testifying, which is a really exciting experience to be part of. But the person who was testifying talked for like 15 minutes about the need for full annual silo conservation, how this program has impacted birds in Central and South America, which has impacts to birds in North America. Shared really great examples about why it's important. And then the Congress people started to ask their questions. And the chair of the committee, his final question was, okay, well, how many birds has this program saved? And the person who was testifying was like, I don't know, like I'll have to get back to you, maybe, like we'll see. But it's that level of question that we need to be able to answer. It's that level of question that our policymakers and our decision makers are operating on. It's not the fine scale, the fine scale science, the fine scale, like, how is this impacting a bird's weight gain? Well, it's stopped over in coastal Alabama. Like, that's not what they're interested in. They want to know top level high information. So I would encourage folks to kind of think at that scale sometimes about, how do we get at that question? How do we answer how many birds is this saved? It's both such a simple question and such a complex one. But I think it illustrates your point really well. I just want to end with this slide. You're not meant to be able to read this at all, but I just think it's so fun. This is outdated. This is a picture of a napkin that was drawn up at a bird conservation meeting because people wanted to understand how the bird conservation community fits together. Who are all the players in bird conservation nationally? How does information get exchanged? How do decisions be made? And so these folks sat down, I guess 10 or 15 years ago with a napkin and just started to sketch it out. And it's incredibly complex. It goes all the way from the state level through regional, through national to international. So this is ignoring like local initiative. This is just states and up. But you can see there's a whole myriad of people who are producing science, who are using science, who are knowledge brokers in this community. It's not a straightforward complex path. It's a whole conglomerated network of entities that are all working together, working separately. They all have their own niches. It's incredibly challenging. It's incredibly challenging to get your head around. Since this napkin is drawn up, it's only gotten worse. Like I said, this is a little bit old. There's been new initiatives and new things that have come up. But it really illustrates the point that the model of producer to user is no longer valid. When you have something that is this complex, there's no way to draw a straight line between those two things. It has to be done through brokering systems. So I'd like to end just kind of with that image in mind. So I want to say thank you for listening to me and having me back at Clemson. It's been really nice to be here, and I'd be happy to take questions with the few minutes that I have left.
Some agencies are having issues with scientists being structurally prohibited from engaging in active advocacy for certain solutions and giving recommendations of what can be done with their work. Do you have any suggestions for ways that people that might find themselves in their careers somewhat stuck to be able to still push forward solutions?
Yeah, every state fish and wildlife agency is different. It's not homogeneous across the board. And so some of those challenges can be ameliorated by what I would call like agency culture. Some cultures, their agency is just really difficult for a specific biologist or specific scientist to kind of get that information up. The best way to overcome that is to get plugged into what I would consider like spaces where the intent of that space is to share information to decision makers. And so sometimes that can take the shape of someone from an agency going to a space where their agency leadership is at and just being in that space and being able to talk to them directly one-on-one. I would say the more feasible it is to seek out these different working groups, different committees the more successful you'll be at getting your information in the hands of the people who need to see that, even if it's interagency. I would also, and I'll try to say this in a way that is neutral. Not every state Fish and Wildlife Agency director has a background in fish and wildlife. Some state agencies, the appointment for leadership is through a commission or a council, and that can sometimes be political. And so we have some state Fish and Wildlife Agency directors who have come to us from like military backgrounds, or they've come to us from like law backgrounds, or you know, they worked with people who are on the commission, that kind of thing. And so it's not, I think there's an implicit understanding or implicit assumption that every director of a state Fish and Wildlife Agency has a background in fish and wildlife conservation, and that can't always be so.
Please correct me if I'm putting words in your mouth, but one of the slides I thought was really interesting. I think you were saying policy in law and organizations is less durable than social change. Could you touch on that a little?
Yeah, absolutely. I mean, so here's a really good example. In the first, well, so who here knows what incidental take means? Okay, so under the Migratory Bird Treaty Act, there's a clause for incidental take that basically says if you kill a bird, even if you didn't mean to, if it was an accident, you can still be penalized under the Migratory Bird Treaty Act for the take of that individual. That's been the long-standing interpretation of incidental take since the Migratory Bird Treaty Act was ratified in the 1900s. The first Trump administration revised their interpretation of incidental take to say that actually the Migratory Bird Treaty Act only applies to cases where you intentionally kill the bird. Incidental take doesn't fall under the Migratory Bird Treaty Act. You have to have intent to kill a bird in order to receive that penalty under the treaty. The Biden administration came in 2021, I guess, and reverted the Migratory Bird Treaty Act incidental take, that interpretation back to what it used to be originally. But there was that course of time where we didn't have a method to penalize incidental take by industry. With the new election that just happened, we're fully expecting there to be another reversion back to the previous the previous incidental take interpretation that happened during Trump 1, that's going to revert that. And so that's an example of like a regulation that has vacillated based on who were the people who were making decisions. We could have potentially gotten like a congressional fix in Congress to say, you know, we could have tried to get a bill through Congress that says this is how incidental take is interpreted, this is the law, this is what we say. There wasn't the political momentum to be able to do that. And so that's another example of like how things can be vacillated back and forth. A social change, on the other hand, is more durable insofar as that if a mass number of people adopt a certain value, that can become the norm, especially when we're talking about like voluntary conservation action. You know, we can mandate buildings to treat their glass to reduce collisions, but if all of a sudden architects across the nation are like, we don't want our buildings to be killing birds, we're going to design bird-friendly buildings, that's probably going to be a much more lasting, durable impact than if we had, you know, an act passed through Congress that says you have to, or that we suggested. Other questions? I will, you know, be around for the rest of the day and talk more during lunch, but thanks for your attention.
We do like, but with like a mile in between. We just kind of really well summarized that I like.